Hey everybody, and welcome to another live training class here at Hero Appliance Academy. Today we're going to be going over ice maker operations on an AK12. Do want to welcome everyone here who is coming through the StreamYard and also now at our YouTube channel as well. So everyone that's joining in through YouTube, welcome, and hopefully you can get something out of today's training class. So like I said, today we're going to be going over the ice maker on an AK12. It's been around for years. The AK12 design, Whirlpool AK12 design, kind of behind here. Everyone's familiar with the 5-door KitchenAid version. Very infamous unit. We battle it every day. But we do see a lot of misdiagnosis on these ice makers, and I get calls, tech line at Whirlpool gets these kind of calls, trying to understand how these ice maker works and the proper procedures for diagnosing these ice makers. From the ice maker operation to the fill tube heater to things that you guys are seeing out in the field, we're going to try to cover it today. Probably not going to get it into too much into the tech sheet and service manual. Just because we're limited on time, of course, but we are going to be getting into the unit and showing you guys how to test it on the unit itself and all the diagnostics running through the user interface here. So the first thing we're going to talk about is we're going to go into the system here and look at the tech sheet and service manual. So let's jump into that. All right. So here we are in Service Matters. Some of you guys might have access to Service Matters. Of course, not this whole training classes that we're doing now. It's not just open for our techs, but to the public. So when I'm speaking to everyone. So not everyone will have access to Service Matters, and we will be sharing the files that we are able to share with you guys, and we'll attach everything to the Q&A section, the comments section, and hopefully through YouTube and here at StreamYard as well. So here into Service Matters, now we got a very well-known model number, KRMF, the 706. Of course, I'm just using the Echo Sierra 01 version. Everyone's familiar with the KRMF 706. Every time I hear that first phrasing of that model number, you can feel the my back tightening up, and I can feel it running up my spine when I hear KRMF 706. So what we're going to dive into is kind of looking into the tech sheet and the several service manuals for this unit. What some technicians are not aware of is that this unit doesn't just have one or two service manuals. This unit has 4 service manuals to it. Each one different from the other, but we're going to go briefly over the difference and the best one to use, and we will share that one with you guys and why it's the best one to use. So one thing I want to touch base before we get into the tech sheet here is last video I did talk about how Whirlpool is moving to service manuals away from tech sheets. That is the case, but on the AK12s, the tech sheet is a vital resource to use when diagnosing this unit. So we're going to dive into the tech sheet first, and I have it already pulled up here. If you're in Service Matters, you'll see the troubleshooting guide, which we will go over here in a moment, French and English. So I already have English pulled up here. And the first thing that most techs will see, they zoom out, when they see these tech sheets, and they see all of this, you get overwhelmed. You don't know where to start. You're seeing all these, tests. I believe this unit has up to 81 tests through diagnostics and all kinds of information everywhere. We have boxes, we have descriptions, we have temperatures, we have several things. We are talking about ice makers. So when it comes to these tech sheets, all I care about is the ice maker. So there's no reason to be overwhelmed when looking at these. It's all about isolating the load that you are interested in. What are you there to look at? Don't worry about everything else. Let's focus on what we're looking at. So just to kind of just give you guys a quick breakdown, let me zoom back in here into this tech sheet. These boxes here are extremely important. They kind of give you more information on specific components on the unit, of course. We're talking about condenser motors. It's going to give you wattages, as you can see here. Give you different wattages, different parameters for these components. They're all within these boxes. Even thermistors, thermistor values. Now, I know Whirlpool is not too friendly when it comes to thermistor values. They typically only share 3 temperatures: room temperature, 36 or 36 to 32 degrees, and 0. That's basically all you will see usually on Whirlpool units. Not saying all of them, but for majority, that's what you're looking at. It's going to, of course, give you current, voltage, wattages for different components. So always remember that these boxes are here for a reason. They're here to help you. It's not about always knowing everything and how to test everything. It's about knowing where to go in your resources to find the answer. All right, another thing that we're going to cover here is understanding diagnostics on this unit. Everything we do in diagnostics for an AK12 unit is through the user interface. And I know, like I said, the 5-door KitchenAid, that's an AK12 design. If you guys are not familiar, the dead giveaway for an AK12 is that you do have that low profile small ice maker on the top left of the fresh food compartment. That's a dead giveaway that you are working on an AK12. They come in dual evap or single evap with a baffle. So to enter diagnostics on these units, it's all the same. It is going to be press and hold switch number 1 and switch number 2. You will see a countdown, a 3-second countdown followed by a chime. Then you know you're into service diagnostics. To exit diagnostics is the same procedure. It also will time out for what we see here, 20 minutes, or disconnecting the unit from power will also get you out of diagnostics. Important notes here. Cooling diagnostic steps are 1 through 6, 32 through 41, and then it goes so forth as far as, dispensing diagnostic steps. It kind of breaks it down and how to get through diagnostics as far as moving through your tests up and down and so forth. We're not going to get into all that, as I'm going to display and show you guys how to run diagnostics. One of the things I do want to point out here and call out is, of course, the diagnostics test and the steps. So each step is displayed in 2 digits on the dispenser user interface. The steps results are displayed in 2 digits on a dispenser user interface. Displays 2 seconds after the step number is displayed. An ember order filter light will tell you that you are in the step mode of that test. When you get the red light, as you can see here, you got the amber for your designated step number being displayed, and the red replace filter light will be the result of that test. And again, we'll cover this as we do it on the unit itself. Just want to kind of call those out because that might be something a customer, I hear this all the time from customers. Why is there a red, replace filter light on my unit when you're in diagnostics? I already replaced my filter. That's how you can tell the difference between being in a test and the result of a test, along with flashing the results as well. Whirlpool did add that feature because some guys do miss those. So, of course, this unit, like I said, has 81 steps. We're not going to go over all 81 steps in diagnostics. We're focusing on everything related to our ice maker and ice maker theory of operation. That is what we're going to be covering today, so we're not going to go through every single one of them. The next thing that we want to talk about is, like I said, 4 different service manuals. This unit has 4 separate service manuals. Each one covers the same basic unit. These are all AK12s. As you can see, I'm kind of going through them all here. The original one, the 2012-2013 service manual, if we can throw that up there, is the number ending in 4924. We're going to get these up to you guys so you can see. If you want to write down these job aid numbers, they will be displaying on your display there. 4924, as you can see, that is the best service manual to use. Now, I'll kind of explain why. This is the only service manual I've ever seen so far from Whirlpool that goes into true detail about the theory of operation on this unit, from the three-way valve, variable speed compressor, everything related on how this unit works. It is listed in this service manual. Again, like I said, there's 4 service manuals for this design, but only one of them actually go through the theory of operation. Let me scroll down here to the bottom to show you. Again, there's no way that we could sit here and read through this whole service manual. It would take hours. All right, so we get into the theory of operation. Again, this is the only service manual for an AK12 Whirlpool design unit that is going to show you proper airflow through the inside of the body, how everything is actually flowing through the internal cavity of this refrigerator for your ice maker, so you know your input air, your return air, even down into your fresh food freezer. It's giving you everything related to airflow. Goes into full seal system operations and theory of operation with the seal system, even down to our three-way valve and how our three-way valve operates. Let me get down here to it, and gives you a good view of the inside of the three-way valve. And if you were to actually read through this theory of operation, you will get to a section of cooling operation and pull down. This will walk you through from the second you plug this unit in to when it reaches temperature, how this unit operates, how it checks, certain temperatures, and how it's moving that three-way valve in different positions, and why it's moving that three-way valve to the different positions. So it kind of goes through full normal cooling, all the way down through component access. Phenomenal service manual. Again, will take you sometimes to get through it. We will share this link on the comment section. It should already be posted for you guys to have. If you don't have Service Matters, the link has now been posted in the comment section. Copy the link, save that link. This is really what's going to save you when you're in the field and you approach an AK12 and you're trying to understand how this unit thinks, operates, and so forth. This is the service manual that's going to get you there. The other 3, of course, we got the one ending in 9537. There's our service manual number there on your screen. This is a good service manual, but this is where we get into the multimedia enhanced service manuals. If you have access to Service Matters, there's built-in videos into the service manuals. This is really going to be more to parts breakdown. These service manuals don't give you any type of theory of operation or anything related to that. It's going to give you use and care. As you can see, I'm just kind of scrolling through, and then you get straight into component access. There's no theory of operation, and then literally everything moving forward is just component access. The multimedia enhanced is going to be anytime you get to a component access section, you will see this little blue play button. If you click on it, it is going to open up a video, and you're going to be able to actually watch it. So again, that is when you're dealing with multimedia enhanced service manuals, that's what you're looking for. Little blue play button. Again, good service manual, but it's not going to give you anything on how this unit works. It's more for tear down and use and care. Same thing, again, with service manual ending in 0550. As you can see on your display, we're looking at the same thing. We're just looking at a 4-door Whirlpool version of an AK12. Like I stated before, the dead giveaway is always going to be, see if I can pull it up here for you all to see. Probably this one probably won't even have it. There it is. Small ice maker, top left of the fresh food. That's going to be the dead giveaway. This is an AK12 designed unit. Your ice box is in the door. Again, good service manual, no theory of operation, really going to go straight through diagnostic steps and into component access. And then lastly, we're dealing with just the KitchenAid 5-door service manual, ending in 8620. It should be on your screen there. again, just about the unit use and care, and then straight to uh, component access. Again, this is a multimedia enhanced service manual. Why Whirlpool chose to do 4 service manuals, really, I couldn't answer that, but we do have 4. I only recommend the first one. That is going to be the one ending in 4924. That is going to be the service manual that's really going to give you full knowledge on this unit, how it thinks, how it operates, and how it gets things done. All right, so the next step that you really want to get into is understanding the troubleshooting guide, how to use it, and really talk about the theory of operation for these ice makers. When you search an AK12 model number, this is only going to work with a full model number. If you do not have an engineering code, a troubleshooter will not pop up as an option. At that point, you will have to go through your resources, go through a troubleshooting guide, and manually look for your unit. Just put that model number back in here. Well, there it is. Again, I'm searching the model. And under tech sheets, my troubleshooter is going to be right there. Let's talk about the troubleshooter and why it's so vital when it comes to these ice makers, because this is where the theory of operation for this ice maker, it's not in any service manual. It's nowhere else to be found on Service Matters. It's hidden inside of the troubleshooter. So if you click on ice maker, once you're inside the troubleshooter, door ice maker, then you have right here at the bottom, ice maker theory of operation. And then of course you have your ice maker not making ice, no water in the ice mold, water is dispensing fine. We're going to talk about the ice maker theory of operation. So it kind of breaks down step by step on how this unit works, but we're really going to look at the flow chart. So we're just going to throw this flow chart up here for you guys to see. This is going to be really what we're going to talk about. So the theory of operation for this full ice maker is when the unit is plugged in for the first time, the compressor comes on and the freezer compartment and icebox fan run on high speed for 15 minutes. After 15 minutes, the icebox fan will reduce speed by 20%. At this point, the board starts monitoring the ice maker thermistor. Once the thermistor is at 16 degrees Fahrenheit and the optics sense an empty ice bin, the board will send voltage to the ice maker motor. This is the only time in the theory of operation for this ice maker that it's looking for 16 degrees. Moving on from that first cycle, we're no longer going to be able to operate this ice maker at 16 degrees. This is only at first time setting up, first time booting up. We're going to get to that 16 degrees before we start sending power to our ice maker. Moving on from that, when the ejector fingers have rotated 360 degrees, at that point the switch will close on the ice maker. It tells the board to turn the ice. Of course, the point of the switch will close in the ice maker. This tells the board to turn on the ice maker water valve for 7.5 seconds. You're usually getting, it says 1.6 to 2 ounces. You're really right there at about 2 ounces. I haven't seen a unit less than 2 ounces. That's usually what you're getting. Again, customer pressure, water pressure is going to have a huge impact on this. As you can see, it's a timed 7.5. So water pressure is going to really come in play here if you're going to get your 2 ounces or not. This will also turn on the fill tube heater and fascia heater for 90 minutes. So your fascia heater and your fill tube heater only turn on after a harvest. So your ice maker has to harvest. If your ice maker is not harvesting, your fill tube heater will never turn on. So you have to go through a harvest for you to get that 90 minute of fill tube heater operation. Once the fill is done, the board will also go into a hibernation cycle for 45 minutes, so no power is applied to the ice maker. So for 45 minutes, that is the time where the unit's pretty much just letting the ice maker sit. Let's freeze those cubes before we actually start paying attention to it. I just want to point out, I did miss a step here. After that 16 degrees in the optic sensing, the ice maker will begin to move and switch, and the head of the ice maker will open. That is to pretty much tell the control board the ice maker has started to move, and the control board is looking for that switch to close again at that 360 degree. So after that 45 minutes of hibernation, the board will start looking at the ice maker thermistor. Here's where our temperatures do change. Once the thermistor reaches 11 degrees, so it's not that 16 degrees, it has to reach 11 degrees Fahrenheit. It will look at the optics to see if the ice bin is empty. If the ice bin is empty, then it will turn on the ice maker mold heater and monitor the temperature. Once the ice maker thermistor reaches 30 degrees Fahrenheit, that's from our heater, of course, it will start to move the ejector fingers to the ice maker. The switch in the ice maker will open. So this is a full harvest cycle. Again, we're right back to opening that switch on the ice maker. Once the ejector fingers have rotated 360 degrees, the ice maker switch will close. This tells the board to fill the ice maker. This also tells the fill tube heater and fascia heater to come on again for 90 minutes. One thing it doesn't point out here is this unit will try to eject ice 3 times before it goes into a hibernate, almost kind of like a hibernation. Let me see if I can find it here. It's kind of hidden inside of the harvesting time. But if the ice maker mold doesn't reach that 30 degrees mark, or it's not able to eject the ice, the unit will attempt that several times. So it even tells you right here, the board monitors the time the heater is on and how long it takes for the motor to switch to close. There's an issue with the timing. If there's an issue with the timing, of course, you'll get an error code. And we'll talk about error codes here in just a moment. So again, all about those error codes. We're going to get into that next. Best place to kind of go through the error codes that kind of tell you more of the theory of the error codes is going to be, if you're in the troubleshooter, you'll have to go through the not making ice article, scroll down to where the fault codes are. Again, the tech sheet is not going to give you a description. It's going to give you a very, very bare minimum. It's going to tell you E2 motor loss position. It's not going to give you really the potential causes of a motor loss position. As you can see, this code indicates a switch in the ice maker is not functioning correctly. This can be caused by a cube jam or the ice maker issue. And it kind of breaks down each code individually and what they mean. The E3 is something that you guys are not going to see. I'm sorry, the E4 is the heater timeout. This would indicate an issue with the ice maker mold heater. The board will attempt to harvest the ice 6 times. If the ice is not ejected, the ice maker will stop for 24 hours and then attempt to harvest again. So this was in a theory of operation, but it's also part of the our fault codes here. And that's what I was talking about there. It will do a, so I believe it was 3 times what I thought it was, but it's actually 6 times before it goes into pretty much a wait for 24 hours before it tries again. If that heater's failed, it's really gonna, you're just gonna be cycling this several times. It's never gonna really eject that ice. E4 is gonna be something you typically don't see. This is a no fill or a dry cycle code. This is a manufacturing software code, so this code may never be seen in the field. That's not really typically something we see. And of course, the most misdiagnosed fault code is our E5. That fault code is the most common fault code while also being the most misdiagnosed. Everyone sees the E5 as a bad ice maker thermistor. It's not. It's a timed ice making. Some older tech sheets actually would label E5, thermistor failure or something of that nature. Really, E5 is a temperature issue happening at the ice maker. Something's happening at the ice maker where you're not getting to temperature. This code indicates the ice maker thermistor is warmer than 16 degrees and the ice bin thermistor has been below 45 degrees for 3 hours. Again, there's a temperature issue. The unit's pretty much going to go into a lockout if those temperatures are monitored. We're looking for 11 degrees, so anything over 11 degrees, we're really going to go into a timed ice making, where this ice maker might only eject ice every 8 hours or so. So again, if you see an E5 fault code, make sure that you are checking your temperatures first. If you arrive into a customer's home and they said that the ice maker isn't working, your first check should be temperatures regardless. Another thing to call out here that is not labeled anywhere, Whirlpool has not said anything about it on any literature, but it is true to an AK12 design. If the unit has a fault code and you replace the ice maker without unplugging the unit from the wall, the fault code will still be stored on the unit and the new ice maker will not operate. The unit's always going to be stopped by the fault code. So if there's a fault code present, regardless if it's an F2 down to an E5, if any of those fault codes are still stored in the user interface, that ice maker will not work, even if it's brand new. So when you put a new ice maker in, you have to clear the fault code. The only way to clear a fault code in an AK12 unit is to unplug it from the wall and plug it back in. That pretty much cycles those controls and clears the fault code, which you should be doing regardless to replace that ice maker, as you don't want to be replacing ice makers while you still have power running through the unit. So make sure you are clearing all fault codes before you're attempting to run this ice maker. It will run in diagnostics just fine, but once you get out of the diagnostic cycle, the customer will never get ice out of this ice maker because it won't operate in normal operations. So now let's actually kind of go into testing this ice maker from diagnostics into the schematic here, and we're going to just briefly talk about it in the schematic. Again, it's all about focusing on what you are needing to look at and not looking at the full schematic. So the most important thing is to look for your road signs. Looking at a schematic is basically following a GPS, looking at a road map. These are road signs. Right here, it's telling me everything inside this box is the ice box itself inside the unit. These symbols here, some people might be familiar with them, some might not understand what these are. These are breaks in the wiring schematic to let you know when you're going inside of the liner and when you're coming out. So you know what's exposed and what's internal of the unit. So everything right here, so this is my first one here. We kind of screw over this way. Everything this way of this mark is inside the cabinet. Everything outside of that is outside of the cabinet, exposed for me to test. So I can get to these connectors. Then my wires go back into the liner. So I'm entering the liner again. This is all inside the liner. And then we exit the liner. We have this connector. Then we enter the liner again and then exit back here. So that is what those symbols mean. It lets you know if the wire is exposed to where you can get to it, or is it internal in the cabinet. That's what those symbols are. These, whoop, just went black there for a second. There we go. That's what these bars mean. These bars are going to mean inside of the liner to inside or outside of the liner. So our ice maker is right here. We need to check power to this ice maker. We can do this from the control or by looking at the schematic. It's telling me to the ice box, I should have a 12-pin connector that I can check power. And right here, going to my ice maker, I'm looking for a white and a brown on pin 1 and pin 5 right out of the box. I can sit here and I can follow this all the way through to my main plug, which is where I need to be. And they should be the same color, white and brown. So we're actually going to go into this unit. We're going to talk about all the diagnostic steps. There is 12 diagnostic steps that you have to perform to verify this ice maker works. So unfortunately for this ice maker, if any of these 12 steps, if any of them are having any type of failures, this ice maker will not function. So let me just back out of here, and we're going to have to jump kind of back and forth through it. and get into it here. So let's go ahead and go straight to the unit itself, and we're going to go ahead and enter diagnostics. Let me get back to our stuff here. All right, so let's get to our unit. Make sure our unit's on. We got lights. All right, so to enter diagnostics, like we talked about, the first two keys, you're seeing your countdown, you see your amber, and then you see your red light. So again, just to kind of move up and down, amber is the test, red light is your result. Your result will also flash, letting you know that you're in the result of a test, not the test itself. So the 12 tests that you do have to run, let me kind of have my computer loaded up here so I can see it while I'm guiding you guys through it. The first test is going to be your freezer compartment thermistor. If your thermistor in your freezer compartment is not operational, you're going to have temperature issues in your freezer. Your ice maker is going to shut down. So it's extremely important to verify when you show up to the customer's home, the ice maker isn't working. Check your temperatures and then run through your thermistor checks. So freezer compartment thermistor, you can see here for my unit, it is telling me it is good. 01 is passing. 01 is passing while I believe here, let me just bring up the tech sheet. 02 is open and 03 is shorted. And as you can see, 01 is passing. There we go. All right, next is going to be our RC thermistor, step 2. And we do have an 02. Now, this is a lab unit. There's a reason that it's an 02. If this unit was to sit running for 24 hours, it would never make ice because we're going to have temperature issues in the unit. The next step you need to run will be test 3, and you need to switch it to step 2 to run the freezer fan. Without a freezer fan, the ice maker will never get freezer temperatures. That's what's helping push up that air into the freezer, the ice maker compartment. All right, from step 3, we jump to test 15, which is going to be your ice level sensor. That's your optics for, let me, all right, we got it on the other one. Your optics are here in your bucket. So as you can see, I am getting an 02. Based on the tech sheet, an 02 is an empty bucket. If I was to place my hand in front of the optics, I would get an 01. I'll just get out of the way here, show it on the display. My hand's over the optics, I'm getting an 01. I move my hand and I'm getting an 02. If those optics weren't functioning, of course, the ice maker wouldn't operate at that point. All right, the next one is going to be test number 36. That is going to be your icebox fan. You want to make sure you feel airflow at your icebox. So when you get to test 36, it is a self-starting test. 01 will mean that it's on, and you would have to manually shut it off by pressing your third switch, which activates tests and diagnostics. 02 means off. 01 means the fan is on. You want to make sure by opening the door, stick your hand up there and that you feel airflow coming out of the icebox. If you don't, you could have an issue with your icebox fan. The next steps are going to be, of course, test 37. That is going to be your icebox thermistor. That is checking the temperatures at the icebox. Test 39 should be our evaporator thermistor in our fresh food section. We want to make sure that that is also passing. And then we jump up to test 56 to check for ice maker fault codes. There we go. Now, of course, I should have nothing there. I should have the E0. This unit was just recently plugged in, and like I said, once you unplug it, you're going to clear your fault codes. So E0 means no fault codes. Now, this is where most guys will jump up to test 57 and run a harvest cycle. You want to avoid that. You want to go to test 58, where the unit is going to tell you if it's too warm to run the ice maker. I'm getting a 00. Let's see what that means in our tech sheet. So jumping over here to the computer, let's go to test 58. It's the ice maker heater activation and the thermistor. So what we care about is digit number 2. Digit number 1 is not really something that we care about. That is turning on the ice maker heater. Digit number 2 is where we really need to pay attention. What's happening here is if you're seeing a 0, the temperature is too warm and the unit won't harvest. You always want to see an 01 when you're in test 58 to let you know that the temperature is cooler than a harvest temp. If I show up to a customer's home and the ice maker isn't working and I check test 58 and I see double zeros, that's telling me I'm having a temperature issue in the ice maker compartment. Sometimes that will be followed by an E5 fault code, but let's say the day before you showed up, the customer had a power outage. That fault code would have disappeared from you. That's why it's important to always follow up by doing test 58. The problem with test 58 is if you run test 57, which is our harvest test, it turns that heater on and heats up that compartment, and then you're going to generate a 00 on test 58. So it's important to check test 58 before you run a harvest test to verify that you are not having a temperature issue. That's just to prevent you from going down crazy rabbit holes that you want to avoid. All right, now let's get back over here to diagnostics. And then we go down to test 57. To activate this test, you will press the third button, which will then start the harvest cycle for the unit, and the ice maker should operate. And we'll talk about the codes for that here in a moment. Once the unit has harvested, you will go down to test 45, and you'll be able to fill the ice maker with water. O2 is the valve is off. Switching it to O3 turns on your valve and the ice maker will fill. Even in diagnostics, you're going to get that roughly around 7 to 7.5 seconds and 2 ounces of water into your ice maker. So let's talk about getting to this ice maker and actually checking voltage. Let's say we run the diagnostics for this ice maker. The ice maker does not run. How do we check voltage to the ice maker without having to pull this whole unit out and getting to the control board? Let's get into it here. Let me grab my meter. All right, so the first step is right here in the filter area. You have 2 points where you would have 2 1/4-inch screws that holds this panel up. So we're trying to get to this ice maker to be able to test it and so forth. So I've already taken those 2 1/4-inch screws out. Now some people will use this fascia heater off, kind of peel back on this front panel and then pull it down. I just stick my hand right here where the filter housing is once I get those screws off and put my hand up here just to hold it and just give it a pull. And it should pop down for you. Once you have it pop down, you go ahead and disconnect your lighting and get this panel out of your way. All right, with the panel out of the way, we can talk about that brown and white wire that we were talking about in our diagram, which is going to be this connector right here. And we're looking for this white wire, and we're looking for a brown wire. Now, some people might have trouble looking at these colors, but this is a tan right here. This is a tan wire. This is not your brown wire. The brown wire that you want to test to is much darker, hidden in the back. So don't get these two confused. You do have a true brown that is considered tan, a tan wire in the schematic. So what we're focusing on is going to be this brown and white wire. That is going straight to the ice maker. What happens with technicians when they're trying to diagnose this is that they'll look for your standard wires, your power neutral and a line back to your valve, and they can get confused with this 3-wire prong right here, which clearly is a 120-volt wire. They'll check voltage here for 120 and not realize This is their heater wire. This is not their ice maker wire. These ice makers are 12-volt DC ice makers. They are not running off the 120. So make sure you check your schematics. I would love to do a video where we just talk nothing but schematics, but that will be later on. So just remember, check your schematics. Really look at your pin layouts before, because you could end up with a false positive and trick yourself into going down a rabbit hole that you really don't need to be going down. So what we're going to do, let me put my meter here so you can see it. We're going to run this ice maker, and we're going to check power to this ice maker here on the brown and white. So I'm going to go over here. You want to come over here. So we're in our ice maker test. We got 0 on our display. Once I press the middle button to start the test, we're going to get a 1 on our display. What that ice maker now is doing, like I said before, it's turning that heater on, and it's warming up that mold so we can go ahead and, eject our ice. There is a delay for this. So of course that heater's got to heat up, that mold has got to heat up before our injecting teeth will push out the ice. So you could be looking at a minute, minute and a half. Don't get impatient and just think that there's an issue. It will switch. What you're looking for is a number 2 digit to let you know the ice maker is moving. So we're just waiting here. We can see we're heating up our ice maker. Any moment now we should see the number 2 digit, and now will tell us the ice maker is running. This is where some guys would just, there we go. We're getting a 2-0. Let's come over here and let's verify. Again, I'm going white, and I'm going back to that brown all the way in the back. Make sure I'm getting good contact. Switch it to DC voltage. There it is. Of course, my leads are backwards, so I'm getting -11. If you see when you're doing DC and you see a negative, that just means your leads are backwards. But I'm getting 11.3 volts. Looking, tech sheets will say 12.7. You're going to be anywhere between 11 to 12. That's within that plus or minus 10%. And of course, you'll be able to hear the ice maker running. You can kind of get in here, open this little door, and actually see the ice maker moving. It's just completed. If the ice maker passes, you'll get an 01 on your display. You get an 02, that's a failure of the ice maker. So an 01 tells me the ice maker was able to do a full harvest. Again, that's about opening that switch when the ice maker starts, and then we're closing that switch on the return and telling the control board the ice maker made a full 360-degree turn, and it's back in home position. And at this point, in a normal cycle, this is when our fill tube heater will be coming on for 90 minutes, keeping that fill tube from freezing up. One thing about these fill tube heaters, and I just want to kind of go over with you guys, this is something that is missed all the time when it comes to these fill tube heaters. I've seen guys replace them because they fail. They put new ones in, and they still get a call back that my fill tube's frozen up again. I just replaced this fill tube heater. Always check voltage. Make sure you're getting voltage to the fill tube heater. Check your model. Some of them will have a 120 volt fill tube heater. Some of them are low voltage, DC voltage. But what I want to talk about is if you verify you got proper voltage to your heater, there's things that you need to do that's going to give you a better performance out of that heater and prevent some freeze up in the future. So let me pull this down, and we'll kind of show this to you guys. Gotta take this panel off to get to the hidden screw. Pull forward, the ice maker will come down. Disconnect all your connectors here. And what we're looking at, here's your fill tube heater. When you replace it, you want to make sure it's tucked in really well. I mean, this, you can clearly tell that this has been taken off and put back on several times. A general rule of thumb that I've always done when I was a tech in the field doing this, if I had to pull this down to get to the ice maker, you got to pull this off. I would go ahead and replace it, because a lot of times when you're taking it off, you can rip it accidentally, you can damage it. It's very brittle, very easily to damage. So anytime I replace the ice maker, I always included the fill tube heater. I'm putting a new heater on. I don't want to take the chance of having to come back. And of course, when you install it, this is for those situations where you are dealing with a return call where that fill tube has frozen up again. You want to take some aluminum foil tape. Let me see if I can get it to pull here with my gloves. Let me take my gloves off. Oh, I've ripped it, but it's all right. Pull your heater wires out of the way. And you want to just wrap it. You want to put some additional foil tape over it. That's going to help kind of insulate it. Because what can happen is, if you look back here in the back, that seal, you could leak air. And what's going to happen is air is going to migrate over to the ice maker, and it could keep flowing over the fill tube and cause it to freeze back up. So having this extra layer of aluminum foil tape will help you. And you want to do, I always done up to 3 pieces, especially I want to get up close to here. I want to get as tight as I can get around this fill tube, really get it, perfectly sealed to prevent it from freezing up again. Now, once I put it back in, I'm not done. What you're seeing here, where this tube comes into the box, there's a big opening. And what could happen is you can get some air leaks around this area. And what is recommended is to take some permagum. You want to take some permagum and just start packing it in there. Really wrap it around, pack around that fill tube. Permagum, when you order permagum, here's the part number for anyone that needs it. I always kept permagum in my van. That's something I use for air leaks, all vibrations around compressors. Permagum, I used it all the time, and you get so much of it. Several little strips of permagum. You want to take a strip and really pack that area up to prevent some air leaks from happening. It's those 2 critical steps that if you miss them, replacing the ice maker, replacing that fill tube heater can still cause you to have, freezing of the fill tube again, and you get that return call. Every time you service this ice maker or the fill tube heater, layer an extra foil tape over the existing heater and pack this area with permagum. That's going to prevent you from freezing up in the future again. All right. So we are now going to go into our Q&A section. There was a lot of information that we're trying to cover. There's nothing easy about this ice maker. It's 12 steps. 12 steps to diagnose an ice maker. Let's just try to wrap our heads around that. And it was actually pretty funny, because I was kind of questioning everyone here before we were getting started, and I was talking about, how many steps do you think it would take to diagnose this ice maker? And I was getting 4 checks. No one got close to that 12 steps that you have to run in diagnostics in that order. So if you go and you run your harvest test before you check 58, you're going to miss that potential misdiagnosis of having a temperature issue. So we are now into our Q&A. Let's see if we got anything coming up. No questions so far. If we don't have any questions, we will go ahead and close out the live for today. So if you have any questions related to this ice maker, any issues you've dealt with in this ice maker, or anything you want to share with other technicians that you have dealt with, you've seen, you run into, feel free. Let's share it. Let's get it out there. Not seeing anything. Also, of course, give us feedback. What do you guys want to see in future classes? Our future class, I believe our next one is going to be, should be on the screen there. It is going to be the 27th. We are going to skip the following class. I won't be here I will actually be working with Whirlpool. I'm going to a Whirlpool training class, so I'll be dealing directly with Whirlpool. Then we will follow up on the 27th. And then we'll go back to our regular program. And then, of course, don't forget to subscribe to our YouTube channel. All of the videos, anything that we do here will be posted to our YouTube channel. So for those that couldn't make it to our live channel, or if you need to revisit, I know it's a lot of information, so you can't absorb all of it. So sometimes you do have to kind of go back and rewatch. So we keep that on our YouTube channel. So make sure to subscribe so you can have access to that. All right, so we're seeing something here. Wiring schematics would be great. Antonio, you know what? If that's what we're getting, we will do a full class wiring schematics. If you're interested in learning how to read a wiring schematic or how to be more comfortable around a wiring schematic, we will do a full hour class on that as well. And it might be a two-parter, just because when you're doing wiring schematic, when you're teaching wiring schematics, there's probably too much to cover in one class. Anything else that you guys would like to see? Any questions about today's class before we get out of here? As you should be able to see our name there, Hero PA Academy. Again, if you just go on YouTube and just search Hero Appliance Academy, it should bring it up. You should see our logo. Subscribe, and you will see those upcoming videos and anything that you want to go back and rewatch for you as well. I know if I was in the field when I was learning how to do this, if I went to one of these units and I couldn't remember how to run all those steps, I would rewatch that video all day and help it guide me through that diagnostics. Next training day is going to be the 27th. You're very welcome, Antonio. I might be blind. That is Antonio, right? Yeah. We will do it. We'll do it for you. So again, next training class will be the 27th. We will not have one in 2 weeks. It will be the 27th, and then moving from that will be every other week like we have been. And we will also be posting, for those who weren't aware, we have done previous live videos with just our technicians here at S&S Appliance, and we will be posting those videos online that you can go back on. We did a full video on the LED issues that these units have. If anyone is interested in readdressing that or need more information on these LEDs, we will address that. Can we see more on the Bella 2? I am working with Whirlpool right now to get my hands on a Bella. I can't promise that it will be a Bella 2. It might be the Bella 1 with the Brow UI. I would love to get my hands on a Bella 2 just because there's so much to do on a Bella 2 and so much to dive into. We can definitely look into that. I was just speaking to Whirlpool about going and see if I can get my hands on units. So if I get my hands on a Bella unit, we will do several live videos and we will fully dissect the Bella unit. Either a Bella 1 or a Bella 2. There's some minor changes between those two models, but in theory, they operate the same. All right, so if we don't get anything, we will go ahead and end the live. And hopefully today's class has helped in understanding these ice makers. As you saw, there's quite a bit of steps that you need to take. Any of those steps, if there's any issues on any of the steps, the ice maker will shut down. You won't have properly functioning ice makers. All right, so we're going to go ahead and wrap it up for today. I appreciate everyone tuning in from our StreamYard and at YouTube. Thank you guys, and look forward to seeing you all again on the 27th.